Let's continue our studies. In this section, let's talk about the myriad reports that are available with pFsense that will help you to ascertain critical information about the firewall in general. So, pFsense reports, and they appear in a variety of forms. So let's list them. You've got various tables, DHCP leases, ARP tables, etc. Graphs, such as RRD, historical, as well as what we'll call near real-time counters, such as pftop, among others. So let's have an exploration of these areas. We'll start with maybe the diagnostics screen. We've talked about it, looked at it briefly, but let's look a little bit deeper at the information that's provided by this wonderful interface. So let's start with maybe the ARP table. So as we know, ARP translates MAC addresses to IP addresses and vice versa. So the forward ARP is usually the IP turned to MAC, and reverse the MAC turned to IP. And that's how nodes communicate on the wire, especially on the same broadcast domain or the same L2 subnet. It's vital for communications, and any firewall interface that's connected to Ethernet will keep track of various nodes, ARP addresses or ARP tables, so layer 2 to L3 resolution and so on. So let's navigate to diagnostics. We've got ARP table, and of course first we'll have to reset the timer. So let's try that again, and then we'll navigate accordingly. It doesn't hold the context, it returns us to the status or the dashboard screen by default. So this is a table, but it's also a report, because generally if you want to know this information from your NIC system, you run a command such as ARP-A, which provides a resolution between IPs and MAC addresses and optionally host names and the interface to which they're connected. So this is the equivalent, again, on any NIC's box of executing, say, ARP-A and dumping the connected hosts to the wire. Similarly, over on the Linux side, you'll get the same information. Well, this is provided in tabular form, and it's quite useful. Actually, we'll keep these windows open just to be able to test connections. So here we see the same information. It shows where it's accessible through EN0, the MAC addresses, IP addresses, and if possible, resolved names. So pFsense does the same thing. So if you need to know the various MACs and their IPs and the interfaces upon which they may be reached, consult the ARP table. It gives us that critical information. In fact, most of the items on the diagnostics screen or menu can be considered reports. So ARP table, there's also an NDP table, which shows IPv6 information, which usually after a while picks up link local information at a minimum. So on the LAN interface, here are some link local addresses of nodes that are connected via EM1 or the LAN interface. Notice the distinct MAC addresses. These MAC addresses are connected to the various link local addresses. They're part of it, the 48 bits of the 128-bit link local IPv6 address. And on the WAN interface, it's picked up this address, which is embedded as well. It's just a table translating link local to MAC addresses or IPv6 addresses to MAC addresses. So you've got the ARP table for IPv4 and NDP table for IPv6 to MAC, whereas you've got IPv4 to MAC. And again, sometimes there are conflicts on the wire. Let's say DHCP lease conflicts or address usage conflicts, or communications inhibiting, let's say, the flow of data between the two correct nodes. Sometimes if you just have a quick look at the ARP table, it may be able to resolve the discrepancy. So you might find the relationship between the IP address and a given MAC address may be incorrect. So maybe 102's MAC address is incorrect. It's pointing to the wrong server, which explains the communications problems. You've got some other what we call near real-time counters presented via the diagnostics table. pfinfo is one such presentation of various counters. This gives us the flow of traffic across interfaces in a variety of methods, including, perhaps most importantly, the number of bytes in and out on a per protocol basis. So one column's for IPv4, the others for IPv6, and it's updated frequently. And it shows you the packets in and out, how many have been passed or blocked. So this is essentially stateful firewall data, state table, the number of entries in that table, counters on matches, various packet components, and so on. TCP versus UDP, any CARP addresses in use, the traffic per interface, EM0 versus EM1. We've generated most traffic through EM0, but since it's been through the firewall, there should be return traffic on EM1. And for any interface that's available, pFsync, which is used to sync pF firewalls, and a pF configuration will show data. So this diagnostic screen gives you a sense as to how much traffic per protocol is flowing through, and it breaks it down nicely. So have a look at this as well, just to see if there are any issues happening with your configuration. So that's Diagnostics pF info, and that's packet firewall, or the pF firewall packet information. Breaks it out by IPs as well as by L4 information, as well as by interface. Another one is pF top. We've quickly looked at. That gives you the top traffic flowing through the system. So if you run pF top, you'll see what's currently occupying the system. So we see 75.3, which is the router's interface, talking to 75.1, generating 10 megs of data. This could be upstream NATed traffic pulling in updates. But you can always see the most activity by generating some traffic. So say you have a large file on one of your nodes, you can send it over to one of the nodes behind the firewall, and that'll send the levels up rather quickly. So for example, let's connect to, say, 101, from which we'll try to maybe copy a file. Let's say we rsync from maybe our ISO subdirectory, an ISO, and send it across. Maybe we'll take something such as maybe a large file. Let's see which one might be of interest to us. Maybe SLES 11. This one might be useful. Let's see what's in here. This is a big one. That's going to be this file, SLES 9x. This should be a large file. This should be about 5 gigs. So generating this traffic over to, say, 1.102, or if we use the NATed address, so say 75.4 to the default port 22 that's NATed into its home directory. Let's send it as root just to avoid any confusions, because on some systems we don't have a Linux CBT user, but rather a Unix CBT user. So let's see what happens if we try to send it as root. So this is sending now at a pretty fast rate, and pF top will catch up shortly to show communications between 101 and 102 on port 22, and it shows the bytes as it grows. And if there's any confusion about the NATed state, just firewall NAT and see where port 22 leads, and that's to 102. 102 is our Ubuntu box. And again, back to diagnostics, pF top, we should see this is the most active stream that's in place. Usually it's TCP ICMP related data that you see. The default view type, which you can view by labels, and this shows you by default labels associated with the different rules, and you can see what's being blocked, passed, etc. Scroll through this to get a sense as to how the traffic passes through. The long view, which will resemble the original view, giving you some sort of presentation of bytes, but sorted by age, how long the packets have been in the queue, by the rules that apply to different packets as they flow through, so drop, INET, pass, so on and so forth, and the default deny, or by the size of the packets flowing by, sorted in bytes, and that should reflect again 101 communicating with 102, transmitting up to 5 gigs, that's roughly 2 point something gigs at this point, or by speed of connection flowing through the firewall. That'll show you the fastest packets as they flow through, and that's usually for the larger connections. So this is transmitted, and you'll see 2 instances of that connection. 2 sessions are open, one for the connection, one for the actual data flowing through. By the state, if they're active, and by the time that the traffic was sourced, or just by the default, which sorts by bytes, and you can sort by destination address and other packet forms and show number of states, etc. So this is a useful interface. Again, this is still copying. Let's see where we are here. This is 60-something%. So if 60% is about 3 gigs, then the full file should be about 5 gigs as it flows through. So pf top, quite useful. Shows top data, shows top traffic flows, with a default emphasis on the size of the traffic that's flowing through. Another one to look at is the routes that are accessible, that are known to your system. So let's take a look at Diagnostics routes, for example. Pretty much any of the entries in Diagnostics can be considered the reports, or to be considered reports that are useful. So you can sort, enable resolution. This will do some DNS translation for you, and number of items. And this shows us the routing tables. This is, again, just like running netstat.rn from the command line. It's yet another report. It's an active report that shows us the latest routing table. Default gateway goes through Linux CBT router 1. If the IPs are not clear, just take off name resolution. So default traffic sent here. The gateway's up. It's Ethernet, 1500 bytes. And we see that a local link is used for loopback. 1.0 goes through link 2. Link 2, we presume, will be 75.3 as a default interface. Well, that means link 2 is the default EM1 interface that it flows through. That's 1.1, that is, and 75 is link 1. And that's a separate interface, EM0, and it shows the route there accordingly. IPv6, any known routes are displayed here as well. And as you add routes, they should show up here. So basically, for the firewall, it knows its route to 192.168.75.0/24 and 1.0/24 because it has interfaces on both. Both of those interfaces are represented as links 1 and 2. The loopback is represented at an offset of link 6. So it knows these two subnets. It should always know how to get to them. So Diagnostics routes, another important item. And as you scroll through, you'll see some other interesting ones. For example, if any of the connected subsystems supports smart inquiries via the smart monitor tools, such as the health of your default disk, which is DA0 under BSD, this returns that it's okay. You can perform various tests in the event that you find problems with your disk or if the firewall is misbehaving, etc. So it's able to talk to the device. You can perform self-tests, but of course this will impact performance, so we'll just omit running any tests for now, but it's yet another report screen that might be of interest. So smart status. And this, of course, works for supported devices. Let's take a look to see what else may be of interest to us. So smart status, sockets. Again, we've looked at that. So what are the current sockets on the system? So these are the various sockets for UDP TCP across both protocols. And it's not showing the states, but showing rather the bindings on the system. So this system does DHCP, as we can see, 67, SSL 80, among NTP and other ports. So those are your bindings across both protocols, IPv6 and 4. And usually the same services are available across both. So here you can see syslog is listening on IPv6 if you wanted to dump traffic using syslog. DNS is also available. So pretty much the protocols are accessible on both protocols, or on both IPv6s. So the ports are available on both protocols, IPv6s and IPv6 and IPv4. And other traffic is listed and so on. And it shows some socket information that may be displayed in the various columns at the bottom. And it also shows the command that's bound to it. So PHP, we've got lighthttpd, which takes care of serving out pFsense, and of course DHCPD to handle those requests, and of course DNS mask, which handles the forwarding of DNS traffic to upstream DNS servers, and NTPD, etc. So Diagnostics sockets, another important menu or report that gives you a sense as to what's running on the system. Certainly those ports aren't published by default. The default will only accept traffic to those different ports if they're open. So DNS, DHCPD, etc. must be open in order for traffic to be received. DHCPD, for example, and DNS are open on the external interface unless you specify on the internal interface unless specified otherwise. For example, if you nmap, say, or if you dig at the routable address 75.3 www.linuxcbt.com, this is the external interface, and unless you open DNS up on 75.3, it doesn't respond. If you query 1.1, for example, if you have access to reach 1.1 on DNS, then it'll allow you, if you're on an internal node and perform the query, then of course it'll work, which we've already proven. So some services, so it may seem as if a lot of sockets are open, and they are, but only some services are available on the external side, such as HTTP and HTTPS and possibly SSH. So that's Diagnostics sockets. You also have states. This shows you the states of the various traffic flowing through the server. So 255, that's always broadcast 443 to 92, or TCP 443 back to our hide port on the address 92 means it's our current connection from this local system. That can be confirmed from any window by just executing an if config to be sure that our local system is indeed 92, and that indicates that we're the one connected to 443. So that is an established session to the remote system on a new port. This is an older port, and this is just NetBIOS related traffic, WINS related traffic for Windows, and this is IPv6 ICMP traffic looking for multicast as well as link local traffic. So these are the states. The states are likely to refresh, so you'll have to search often or do refreshes or rerun the screen to see new states. As connections are open and closed, they'll oscillate accordingly. So for example, by virtue of refreshing this page, a new socket, because of course HTTP times out, so a new socket was open, still related, sessions kept, but HTTP by default has no relationship across connection points without using keep alives, or, well, to make the connections faster, or session management using PHP in the web server, etc. So you'll see a number of sockets in the established time wait states as you use the web interface when you look at the states table. Here we see a state from 102, which we know to be our Ubuntu box, through 75.3, which is external, out to 216, and this is for NTP synchronization. So that server must have an NTP sync that references this particular node. And of course, you can look these items up, just do a DNS lookup, give it an IP. It should know whether or not it should perform a forward or a reverse lookup to tell us what that node is. It'll perform a lookup online, come back with information wherever possible, and that's yet another report. But of course, it's a diagnostic tool, so we'll keep it off the list. So sockets as well as states, and that comes back as mars.org, services, so on and so forth. That should be an NTP related item. So states returns the current states it's changing, so it's a report. Let's take a look to see what else may be of interest from diagnostics. So state summary. This just gives you a counter summarization of traffic flows. So 102 has 2 states, 75.3, which is the router's edge, has 5 states, 92, which is our Mac OS X instance, has 17 states as we refresh these pages. More and more states are created. And this is by source IP, and by destination IP, you can see the most popular target is 17, has 17 states, which is 75.3, whereas 101 and 102 have 2 states. And by destination, this must be a reference made by one of these nodes or both of them to communicate with perhaps security Debian or NTP or otherwise. And total per IP, so 75.3 in total has 22 states, 92 has 17 states. And by pairs of IPs, well, 92 is connected to 75.3 17 times. 102, which is our Ubuntu box, is communicating with this particular node twice. And just some loopback activity for UDP and some more UDP activity. So this is yet another useful report, but refresh it often because it's a moving target. You'll see new state information and new counters as you oscillate through the state table summary. So that's state summary. System activity. This gathers the processes that are running. This is equivalent to running top and shows you, or similar to running top, which shows you how much memory, how much swap. Expect this to be free as usual. How long the system's been up. So it's like running top, which includes uptime, etc. The processes, they for the most part all run as root. You'll see some references to PHP, the pinger, which checks to see if the router and other nodes are up, kernel swapper, and so on. So state summary, as well as we've just mentioned, this is our top like system activity dump, which shows you processes. Why is it important to look at this? Well, if you have a snapshot, an idea of what your pFsense firewall is usually doing, so the username being a default of root usually, and certain processes such as PHP, NTP, apinger, clock, etc. When you notice anything that doesn't match this common list, then it could be cause for concern. Or if you see a process in a state that seems unusual, such as zombied or sleeping or otherwise when it shouldn't be, then it could be a reason to restart the service, maybe DNS mask if DNS is not resolving or otherwise. So that's why it might be important to take a look at this. Then under the diagnostics, you have various tables, which we've already talked about. They're just lists or aggregates, such as the Bogon networks, which includes loopback, which isn't permitted by default to traverse the router, among other networks that may be of interest. So that's just another table. And you can test ports, as we've mentioned, and you can trace route to see whether or not services are available. And as you look through, you'll see other tables, such as status DHCP leases. That tells you what's happening with your DHCP configuration. So status menu, DHCP leases for both protocols, of course, but version 4 is still a common one. This one has a screen to show all configured leases, which includes leases that are no longer active. Only 3 leases are active for us currently, 2, 3, and 4, or 102, 3, and 4. And default times, you can take a look at them, make some changes, add a static mapping so that the server always receives that particular entry, so on. We'll look at that in the DHCP section. So that's yet another report that's of interest. DHCP v6, in the event that you have a prefix configured, might be of interest for you to look at as well. Some other areas, as we navigate through, you'll see, for example, RRD Graphs. We haven't looked at this. RRD Graphs give you histogram information concerning key metrics. So for your system, you'll see graphs concerning processor, memory, throughput, etc. So here's a processor graph, and this shows us utilization number. Now, as you can see, only a few spikes here and there, especially when traversing a lot of data or transferring a lot of data. But for the most part, it's pretty unused, underutilized, which is what we expect. The average is pretty low. And it's broken out into nice user, system, interrupt, per number of processes, etc. And of course, it's spread across various amounts of time. So the first one covers 8 hours with a 1-minute average. The next one covers a full day with 5-minute average, which gives us a broader view. And as you scroll down, you get broader and broader views of the usage. So 1 week with an hourly average. And then finally, we see here a monthly usage, and then, well, also up to year, up to 4 years, but those have no data yet. So for us, it's just the monthly, which gives us a sense. So on average, over a month with an hourly average, we're about less than 10%, maybe even half of that with some spikes here and there. But if you look at it with a more narrow lens, such as for the last 8 hours, well, for the last 8 hours, it's been rather busy here and there, but still not so busy. So you can sort by the different key metrics. Looking at, say, memory, for example, how is the system's memory? Well, we've allocated a gig to its usage, so how is it looking? How much is used? Well, free shows you that, for the most part, 90% of the memory is free. It's dipped in some cases to 80-something, high 80s, as low as about 80% free, which means about the converse of that is in use. So you'll see for active here, 10 up to about, maybe say, or below 10 up to about above 10 to cover for the space here is what's used. And then there's some that's inactive, cached, and wired, so they take up the difference. It's BSD. You'll see the same representations on Mac OS X again as well. And you'll also see the same data presented over a broader period of time. So the 5-minute average for a full day, month, all the way up to what we see is 4 years. These RRD graphs can be configured for any length of time, but nonetheless, you get the point. Processor, memory, the number of states moving through the system. So is your firewall handling too many states over the last 8 hours or 1 day, for example? Well, this shows us system PF states, systems PF rate, systems PF NAT. Is it natting too much? Are there too many system states? How about the destination IPs or source IPs? What sort of graphical activity gives a sense? Well, we see PF states. On average, this looks like maybe somewhere in the ballpark of 40 to 50 states. That's no big deal. So that's really low utilization for any type of system nowadays. But you can look at the states, because again, if you're even close to the 100,000 permitted states by default, then you'll want to increase the resources and up the amount of states that are supported by the system. The throughput. Well, we just copied a 5 gig file, so we generated a spike, and that generates in and out traffic across our interfaces. So for the last 8 hours, we generated that, but across the board, there isn't much utilization. We haven't been moving much packets, so we'll see over a full day, just a quick spike here for that large transfer, and a broader view shows not much activity whatsoever. So the utilization is rather low, and you can just look at the top end, so 200 megabits per second. The interfaces are gigabit interfaces, so not much happening here. So at one point we hit just above 5% of the capability of the interface for just a short period of time. This is 1 minute average over 8 hours. If you split this out, this time block here covers essentially 1 hour. So in this little blip here, you're talking maybe 10 minutes of activity to cover that 5 gig file at a rate of about 200 megabits per second. So that's no big deal. We're not exercising or over exercising the interface. And the memory buffers, or you can just look at all graphs, but we know we're not exceeding our resources. But you'll want to pay attention to these graphs for production systems, especially those concerning memory, processor, and the overall throughput of the system, to ensure that you're not overrunning the interfaces. For example, during times of archival, such as backups, etc., you might find that you're overrunning your interfaces, although it's generally suggested that you use distinct interfaces to handle those sorts of traffic. And of course, you have one dedicated to traffic. And this can show you graphs for the different interfaces. So the WANs handle a spike of 200 megabits per second when we were copying that large file. We should see the converse on the LAN. So it happened to cover that on the reverse. So it goes in one interface, out the other. So it shows it as an inverse. But if you look at it as an absolute, then obviously it'll show it in that view as well. And you've got different traffic points outbound. How does the traffic look going out? Well, here's the traffic on the outbound side, and it's of course rated over a certain amount of time with different averages, so 8 hours, 1 minute average being the default. If you've got IPsec, well, we don't, but you'll see traffic pertaining to just IPsec as it's flagged independently, and you can look at all graphs if you'd like to get a sense. Similarly for packets, how many packets are going in and out of the system? So here's the breakout, 8 hours, 1 minute, packets per second. So we had a spike with that large copy shooting about close to 20,000 packets per second. But again, for a gigabit interface, that's not a problem whatsoever. Quality concerns can be looked at here to get a sense for the milliseconds response over time of the interfaces altogether. So of course, during the time we move the data, we expect the quality to drop because we're sending through a lot of data. And again, on production systems, if it's a problem, then that's something you want to look at. And you can look at any of the different types of graphs that are available, so the WAN traffic altogether. Same information. We don't have much to show at this particular point. You can clear all the data, wipe it out, etc., and start all over, but it's nice to keep a histogram going. So you've got RRD graphs, you've got system logs we've looked at, you've got traffic graphs. This is closer to real time. This is updated frequently and shows you the traffic in and out of the system, defaulting to the WAN interface. So currently input on the WAN interface, which means from the outside, is a mere 3 kilobits per second, and output going to the LAN is 4 kilobits per second. Again, that could just be updates or broadcast traffic being filtered and discarded. And you can flip the interface maybe to LAN to see what the LAN's doing. And of course, if you generate traffic by copying a file, that's going to generate activity as well. So say from that node ubuserve1, let's SSH to 192.168.75.4. The default port should connect us to ubuserve1, from which we should find that ISO file. Let's see if we've got anything here, and actually it might be under root, so let's su in as root and find that file, *ISO, and you can see packets are being recorded in the back as we type and interact. So if we then try to rsync this file, let's say star ISO back to say the internal node, say 75101, this of course will shoot the traffic up. It's just a simple example of us moving data through. This will shoot the traffic up, and this near real-time graph will accommodate it. Notice we've gone from merely kilobits per second to hundreds of millions of bits per second. So this is roughly 250 megabits per second with total capacity of a gigabit or 1,000. And again, with production, you're going to get much more traffic flowing through. So pay attention to this keenly over time. Now, it's on the LAN side. We've sourced the traffic from the LAN hiding behind pFSense, sending it inbound on the LAN interface, and that's why it reflects accordingly. Outbound is just control data coming back in and other data of return packets. And from the WAN perspective, let's take a look here. So now the WAN should show the out sending packets off to that 192.168.75.101, whereas the in is just control data and other traffic that's being sourced and generated by the other two nodes and other processes on those three various systems. So it correlates. So input, LAN, output, WAN, when traffic is sourced from the LAN heading out to the WAN, and conversely when traffic is sourced from the WAN heading to the LAN. Let's see what sort of transfer rate we're getting here. This is oscillating 20 to 30 megabytes per second, so multiply that by 8, so 160 to 240 megabits per second, giving us roughly, say, about up to a fifth to a fourth of maybe a gigabit per second, which is not bad. So that's yet another report that's of use to us. That's that traffic graph report. And anywhere through the interface you see any sort of data that may be returned, you can consider to be a useful report that gives you a sense as to how the system is behaving at any given time. But most of them can be found in the diagnostics screen. And you take a look at any of them, for example, a state summary. And if you look at the IP pairs now, you should see 75.101 pop up with 1.102, and it's sending through data. And let's see if anything else is of interest. pftop will now show these two as the most communicative. So 102 and 75.101 sending through almost the full 4/5 of 80% of that 5 gig file. And just look through here to get a sense. If we take a look at the RRD graph for the network throughput for traffic, besides CPU activity, we're going to see 8-hour, 1-minute average. This will update eventually to show traffic flowing through. Let's see if we've got some stuff on the LAN. This should be input traffic. There's the input coming in on the LAN. And this is our over 200 megabits per second flowing through on the input side of the LAN, which means the WAN will reflect the converse of that as it leaves the LAN. So it's showing it below the 0 on, or the x-axis 0 indicators the reflection of the traffic. So this indicates that the traffic is leaving the interface. WAN 0, WAN that is, versus on the LAN, it's entering the interface, which is why it shows up here. But this will be done shortly. Let's see where we are. 97%. So it's just going to be another one of those blips. It doesn't prevent other communications through the firewall, so it'll just continue to operate as normal. And again, just look through for anything that might show you useful data. So pftop, pfinfo. pftop is going to show you when the bytes are pretty much and how many packets it took to move those bytes. And pfinfo, that's about right because 1500 is the size of those Ethernet packets. So it's 5 gigs, so you're going to have about 5,000, close to 5,000 packets, just a little bit less, 4,000 something packets flowing through to make that transfer occur. There it is. So the blip's over. So our RRD is going to go back to normal, RRD graphs, and take a look at traffic throughput on the LAN interface, reflections on the WAN. And there's it. That's the spike. It's going to go back to normal, and that's on the books. It's in the record books for that particular instance. So those are some of the reports that pFSense can provide you with that are extremely useful and can show you what's happening close to real time. It's not all real time, as we've mentioned. Even with status traffic graph, it's refreshed often, and often enough for you to get a sense of the behavior flowing through the firewall. So currently, nothing much. We're back to normal on the WAN. Let's take a look at the LAN. And this is sorting by bandwidth in, but you can look at it bandwidth out, either or, just to get a sense for how traffic's flowing in and out of the interface. And this does a local filter, but you can filter on someone else, a remote system. Low activity yet again, and you can filter it by these as well. So a little bit about reports. Let's move on to some other items.